Worksheet 2 on solution stoichiometry is just some more model problems, or contains model problems on solution preparation. Got 3 from each case, solid, liquid, or concentrate. And then we get into the meat of the solution phase reactions, which is really the bulk of what you will be facing as we move forward into the kinetics, equilibrium, and thermo. Anyway, so let's finish these 3 solution prep problems. And just to review this for a second. Okay, so the first one is saying prepare 500 milliliters of 1.5 molar sodium hydroxide from manufacturer stock that's 98% pure. So need liters of a 1.5 molar sodium hydroxide, and that's 98% from wherever you buy the sample from. Well, it's just a matter of grams of the sodium hydroxide needed of the solid, and that's molarity times volume needed in liters times formula weight over the purity factor. And so again, the molarity needed is 1.5 molar, and the volume is 0.500 liters. 500 mils is half a liter. And formula weight for sodium hydroxide, 2333.40 grams per mole. And that's divided by the purity factor of 0.98. And so everything will come out in grams. So for a solution like this, 30.61 grams plus solvent up to 500 milliliters. And so you should be getting comfortable with this idea of manufacturing or preparing solution from solid. So one of the exercises you'll have in lab is to prepare theoretically a certain concentration of solution in sodium hydroxide, and what you're going to do is calibrate that and see exactly what the true concentration is using a titration procedure, which we'll show you later next class. So when you do make a solution like this, 99% of the time it's not going to be exact. It'll be very close, and you can count on that. But the purpose of doing the titration is to find out exactly what it is, using a standard to titrate the sample. And it says prepare 1,500 milliliters of 2 molar hydrochloric acid from a 37% active solution that's got a 1.14 specific gravity. So we're going to prep 1,500 milliliters or 1.5 liters of 2 molar hydrochloric acid solution from manufactured 37% stock. Okay, specific gravity is 1.14. So how do we do that? The question is, what volume do you need of the concentrate to dilute to the needed volume, 1,500 mils. So in this case, the volume will come out in milliliters, and that is a molarity times volume needed in liters times the formula weight of the solute divided by purity factor, but you must include also the specific gravity in this one. We need to make a 2 molar solution. We need to make 1.500 liters, 36 grams per mole for the formula weight. Purity factor 0.37% or 0.37, and 1.14 grams per milliliter in the density. Okay. So that'd be 2 times. I get 256 milliliters of HCl 37%. And caution, add the 256 mils of HCl 37% into, say, 500 milliliters of solvent water. Mix and then dilute to total volume, 500 mil to needed volume. So just to re-emphasize the safety factor in that, mixing the strong acid, you don't want to try to pour water on 256 milliliters of concentrate. You will have a problem. So we have to prep 100 milliliters of 0.05 molar sodium hydroxide aqueous solution from stock at a 2.0 molar solution. So it's really what volume do you need to start with, and then dilute to the needed 100 mils. So this is use of the dilution equation, molarity times volume before dilution is equal to molarity times volume after dilution of the diluted sample, or concentrate to the diluted. So you're trying to prepare a 0.05 molar and 100 mils. You can leave these in milliliters if both sides of the equation are the same units. And so this one's volume before, which means how much do you need to extract, and you have a 2 molar solution. Solving for volume before, that's the amount of concentrate needed, is 0.05 molar, 100 mils, divided by 2 molar. Molarities drop out, units come out in, well, that's 100, that's 2.5, I guess. Yeah. 2.5 milliliters of 2 molar stock, lab stock. Okay, needed. And you take 2.5 mils and dilute it to 100. Now, you don't have to go through any cautionary issues with the lab stock dilutions like that. It's usually pretty safe and use reasonable procedures. Okay,